Hi, today I want to present you a practical Scala introduction. This presentation I will talk about several topics from the Scala language, from some basic stuff to some more advanced stuff. The idea is to give you a general overview about Scala language as well as some applications that you can where you can use it. In this presentation, we are going to talk about Scala, some stories from companies using Scala, some examples of Scala code and what to show you what you can do. We are going to talk about unified type system in Scala, strings, type inference, higher order functions, currying case classes, algebraic data types, pattern matching, error handling, the option the option type in Scala, and last we are going to cover a little bit about weak types and strong types, which is a way for detecting more errors at compile time instead of failing at runtime with exceptions. This is a lot of material and everything will be covered very briefly. So the idea mostly is to give you a general overview, very practical overview. Scala, it's a multi-paradigm language because it's object-oriented and also is a functional language. We have object-oriented based on Java because Scala runs on the Java virtual machine. In this case, it's inheriting all the advantages from Java virtual machine, like the several libraries the several libraries and frameworks that are existing in Java virtual machine, and we are also getting all these advantages from Java, which are like null pointer exceptions, the usual way for error handling, throwing exceptions, nulls, and type erasure, and several other disadvantages from the Java virtual machine. Scala also is statically typed, which means that more errors can be detected at compile time. The good thing about Scala is that most of the times you are not required to write the types in your programs, which makes you feel like you are using a kind of dynamic language like Ruby or Python. This helps you to be more productive. Scala is also very extensible. There are several applications or frameworks that use its own domain-specific language. For example, Spark, Finatra, Play, Sleek. There are several applications having its own domain-specific language because Scala is flexible enough to let you do that kind of things. Talking a little bit about companies using Scala, we have the amazing case of PayPal, where PayPal was telling us that they scaled to handle billions of transactions per day using only 8 virtual machines. In the past, they were deploying hundreds of virtual machines, and now, uh, in the age of this post, they were using only 8, which is amazing because the complexity is reduced a lot. Every the more instances that you need in order to run a project, the more complexity you have. The less instances, the less pain that you need to do a deploy or to debug the code, and it is really awesome. We have also another company called HotSuite, which is scaled to handle billions of clicks, and they are hoping to go beyond using Scala, specifically the reactive platform from Lightben. We also have Wix, which is another company who started scaling from 5 to 15 million of users using the reactive platform with Scala. And of course, we have also Samsung, which it is growing at a startup speed using Scala technologies. Samsung is a very big company, and they are using Scala to grow very fast and deploy code in a way that is most scalable. In talking about the simple example that you can find in Scala, we have the hello world. And a hello world can be as simple as this. We are defining a singleton object called main with the main method defining receiving a list of arguments. This is the list of arguments that you are passing when you run a program from the command line, and simple calling an instruction to print something to the standard output or the command line. And we could even reduce this hello world to something like this, where you're extending the app and using this code like it were a scripting language like Ruby or Python, which it's even simpler than the first application. And now I would like to talk about some code examples in order to let you know what you can do with Scala. In this case, we have a class point where it has a constructor receiving two arguments. In this case, both of them are integers. This represents a point in a plane. We have the point x and the point y. The modifier called val means that x and y are immutable. It means that it's a value. Once you have assigned these values, you cannot assign anything else. And in fact, this class, we are defining the point class as an immutable class. We are defining a method called move, where we are receiving some deltas, delta x and delta y, and we are moving our current point to another position based on the deltas. As you can see here, this method have the return type in the signature, which is another point, and it also has some default values. In this case, when calling move method, is we don't provide the parameter delta x, it will take the 0, which is the default value, and in the same case is for y, because it has the default value as 0. You can provide 1, 2, or none of them. And we are also creating a new point because the class is immutable. And here is something beautiful. This seems like if we are overloading some operators, in the case of the plus sign, to some 2 points, while this is not necessarily true, because in Scala everything can be a method. We have the plus sign, but there are several methods using some strange symbols. And what we are doing here, different to the move method, is that the type that is returned is not specified but is inferred by the compiler. In this case, the compiler is inferring that we are returning a new point. Also, as Scala came from Java, it's running in the Java virtual machine, we can override the toString method to represent an object as a string. But in this case, we need to place the override modifier. It's a mandatory thing when you are overwriting something from a superclass. And our method is returning a string, and we are seeing here a string interpolation where x is evaluated as well as y is evaluated to the values of the arguments of the class. There are two syntax different here. One is shorter and another not so short, and we are going to cover a little bit about them more in more slides. In the last part, we have a singleton object called point, which in this case we are defining a class point and the object point, which means that the object point is the companion object of the point class. This can be a new concept for you, but we might cover a little bit about the companion object later, or we might not, I don't know, we don't have too much time. And we can see here that we are defining a lazy value. This lazy modifier that you see before the value origin means that the value will be computed only when some class or some object requires this value called origin. And if we don't require the origin at all, the value will never be computed. If you are familiar with Haskell, you can remember something similar with lazy evaluation or lazy values, and it's very similar. And we have more examples here. We can see that we can access the lazy evaluated value called origin from the companion object, and we can try to move the origin point by 1, And as I told you before, this one represents delta x, and we are not providing delta y, which means that delta y is taking the value equal to 0, the default value. And as you can see here, point 1 have x equal to 1 and y equal to 0 because it's the default value. And also we are declaring point 2 with a different syntax. In this case we are providing delta y but not delta x. We are using something called by named arguments, where you are invoking a method and passing arguments by the name. In this case, delta x is taking the default value. This is something that is very useful for several applications, or for example when you are using libraries that require several parameters. It's usually better to use this syntax in order to avoid confusion between the order of the parameters. Another fancy thing that we can do in Scala is, while declaring point 3, we are taking the sum of 2 points. And in this case, we are using infix notation. As you can see here, this can give you a more natural feeling. While, as I told you before, this is not really an operator, but a method. And anything can be a method in Scala. Also, we can access the attributes from a class, from an object, using the doc syntax like most object-oriented languages, let's say Python, Java, Ruby, JavaScript, and we're accessing here the x from point 1, or we can transform and print a point to a string, exploiting the toString method that came from Java. This is representing the object as a string, as you can see here, but this s is a mistake from my side. And something useful that you can use in Scala is to write the extension methods, as you can do in C#. An extension method can be seen like you are extending what an object or a class can do, but not modifying the class directly, like using extending a class with a subclass, or using monkey patching in the dynamic languages like Ruby. In this case, we are seeing several advanced features like implicits, extending any value class, but we don't care about this today. In this part, we are only looking like we have a method called the scale. We are receiving an argument, and we are scaling x and y by that argument and creating a new point. And of course, if we try to call the scale method from point class, we are going to get a compile error because scale is not a member of class of point class. But as I can show you here, we can do a little bit of magic. We can import our implicit extension class and call the scale method on point 3, and the compiler will detect this and will give you a more natural feeling. This is better than monkey patching, because if you need some extension methods or extension classes, you can just import them instead of Ruby, that if you modify something, I can go and modify the same thing that you modified in another class, and something will be a mess, and there are some hard to track bugs there. In this case, that's not possible, and it's very useful for writing domain-specific languages as well. In Scala, as I told you before, is running in the Java virtual machine, and the Java virtual machine has objects and also have primitive types like ints, doubles, floats, booleans. In Scala, it's a pure object-oriented language because everything is an object. In this case, Scala has collapsed everything to be an object. And we can see that we have a superclass called anyRef from any reference, that it can be seen as exactly the same like lava.jan.object in Java, and every class that you write will be subclassing directly or indirectly to any ref class. Like we have a list, the option, or the point class that we saw in the previous slides. Also, in Java, if you remember, the primitive types like the ints cannot be null, and in this case we are respecting that, and we have a null subclass that can be used only in objects from Java, from any ref class. And on the other side, we will have the any value class that it has a limited number of classes, of subclasses specifically, like all the primitive types in Java. And also we have the unit data type extending any value in Scala. The unit can be seen as a void value in Java, some type that represents nothing, represents no value, but it's useful because Scala it's a functional programming language, and in functional programming every function needs to return some value. In this case, if you need to return anything, just return unit. And the last part, we have nothing being a subclass of every other possible class, like from any value or from any reference. The difference with nothing is that it can be used in any value subclasses instead of null, because null can be used only in any ref subclasses. And one use case for nothing is Scala have a placeholder where you can place three quote marks, three question marks together, which means that we don't know exactly what are we going to do there. We don't have the implementation, but we can get the code to compile. And in the case that we try to call that method in runtime, we are going to get an error. It's useful for prototyping or when you are not sure about how are you going to write some things, but you need to compile the program. It's one use case. You can read more about that in the Scala official documentation. In the case of Scala, we can represent strings in several different ways. One way, the simple one that it's not here, is using quotes like in several languages, but in this case this example is not here. The simple example that I have here is to use a string interpolation, like in this case we are replacing the x value using the prepending the dollar sign, and as you can see the string can be evaluated to give this result, which is x equal to 5. Another syntax for string interpolation is to use the dollar sign and a bracket, which allows you to perform more complex operation, like calling a method from an object, in this case list.head, and we are getting the result like head equal to 1. Head is the first element from the list. We haven't seen collection so far, but it's the first element from the list. Another very useful feature is that we can write multi-line strings, and the way is to use three quotes together instead of only one, and you can write quotes inside the multi-line string with no issues. And this becomes very useful for several applications. Another way to write this is using a multi-line strings using a margin. In this case, the pipe character is being the margin of this multi-line string, and we are calling an auxiliary method for stripping this margin. The result of this operation will be exactly the same as the result from the first multi-line string that we have. And one example of what we can do using multi-line strings is writing beautiful SQL queries, for mentioning one example. I have to warn you, because this has SQL injection, is mostly for educational purposes that what you can do, because it also allows you to do a string interpolation, replacing some placeholders by some values, with the advantage that you will have an error at compile time if the value doesn't exist, and we are using the margin, and this is beautiful. And a drawback about this, the string interpolation that we saw before, is some people can tend to use this kind of complex strings, like abusing the syntax, that using the dollar sign with a bracket, you can place anything there that can be evaluated. So we have a complex evaluation here, that having a list and getting all the numbers that are even and multiplying every number by 2 and summing the result, and we have a result equal to 12, but this is awful. Please don't do it, because programmers that are going to take this code will have a really hard time trying to understand what is this trying to do. Also, usually the IDEs like IntelliJ doesn't paint very well the syntax, which you can confuse very easily that the whole thing is a string or a multi-line string, when in reality this is not. Please don't do that. In the case of presenting a value as a string, we have already saw that we can declare a class and override the toString method that comes from Java, and we can simply represent this as a string, as you can see here. The problem with this is that you don't really know when you can represent an object as a string or not. For example, in another case, we can have some garbage. There is no way to detect at runtime if you can do this or you cannot do this, or maybe there is not a simple way or a reliable way, because everything can override this. And as you saw here, we are getting some garbage. Another thing that we can do to overcome to this limitation is to use case classes when we need a default to a string method, because case classes are very useful for several things. Like a case class by default is immutable and has several advantages. We are going to cover more about case classes later, but the important thing is that we have the toString method implicitly written by the compiler. And if you want a more reliable way to detect when you can represent an object as a string or not, you can take a look to some functional programming libraries like Scala C or CATS. They have something called show that it's similar to the show from Haskell, that will let you check if you can represent something as a string. It's very useful for some applications. Talking a little bit about type inference, in the past I told you that a good thing about Scala is that most of the times you are not required to write the types for the values or functions. And we can see here that in the first example we have detected that x should be an int. The value s, it's a string. The compiler is detecting this, and we are saying this new syntax that can be new for you, that is a way for representing a function that takes an integer and returns an integer. And while this is very useful, it might not be really correct, because we could have an integer overflow in this case and have it an unexpected result. But I think that is good enough for the compiler to allow you to detect these kind of things. Type inference also can work in methods. For example, defining a method that it's taking an integer and returning the extreme representation of this integer, and the compiler is detecting that the result should be a string. This is very useful. Also, when we are trying to print a string to the standard output using printLine method, the compiler is detecting that we are returning nothing, no useful value, so the result is unit. As I told you, it's similar to void in Java. And not everything is good, because we could have some unexpected inferred types, and in some cases, like supposing that you miss the else case here in Scala, and as I told you, everything returns something. The if can be seen as a function, and in this case the compiler is getting the first type that can represent every type that is in the conditional. In this case it's any, and while I will have preferred to have a compile error, because this is wrong. If I am writing and depending everything on type inference, I can have some very unusual errors that can be hard to debug. So it's better, one way to overcome to this is to specify the return type that we are expecting to have in this value. If we had placed a string here, we are going to have a compile error. And this also happens in functions. If you have a function that is returning only something when certain condition is satisfied, and in this case the expected result should be a string, but in reality the string is not inferred, but any is inferred, and you can have complex issues in your application. So try to a good rule is, if something is public that can be used from outside of the given class, declare explicitly the return type, and this can help you to detect several errors. And also, type inference doesn't always work. In the case of recursive methods, you are required to specify the return value, the expected type that the function is going to return. And so you have to be aware of this. Now, talking a little bit about higher order functions. You might already know about higher order functions, but you might not already know the name, because if you have used languages like JavaScript, and every time that you are passing a function as a parameter to another JavaScript function, this is a higher order function. A higher order function is basically a function that can take a function as an argument, or can also return a function as a result. We can see this method called f receiving two arguments of type int, and receiving a function that takes two integers and returns another integer, and it's performing a call to this function that is passed as a parameter. This is a very common practice in JavaScript, or like Node.js, passing callbacks. And supposing in this case we can define a method called sum, taking two integers and returning one integer, we can perfectly call the function f, passing two int arguments and the sum function, and we are getting the result evaluated to 5 because this is a sum and it's correct. And there are another ways that we can do, like passing an anonymous function, and this is the syntax to declare anonymous functions in Scala. In this case we are performing a multiplication, and this is working. Again, we have the 6 as a result value. And using higher order functions, we can get to another concept called currying. Currying is a functional programming concept that allows you to define functions that takes several argument lists. We are going to see a little bit about this. Like if we declare a filter function in this case, we see that we are having an argument list first that is receiving only a list of type integers. This syntax that you see here is to specify that the list should contain integers only, and this is an argument list, as you can see, is separated, but we can also declare another argument list that is required to specify a complete call to the function, and this is receiving a predicate that it's having an integer as a parameter, perform some evaluation and returning a boolean. In this case, we are going to, the function filter is going to return the list of integers that are satisfying this predicate, and the predicate can be something that you can pass to the function. And just to place an example, we can create an integer list, and using the infix notation from Scala, this is one of the things that I told you, that Scala is very flexible. This feels natural, 1 to 10, and it's creating an interval from 1 to 10, and we can map this to a list, and we can call this higher order function and currying, and like a filter, for example, we pass the integer list, and as the function we are checking if the integer is an event, and the result will be a list having only the events numbers from 1 to 10, which is correct. There is another useful syntax that we can use here, like using the underscore. The underscore basically represents this syntax that we are seeing here, but it represents like the first argument, take the modulo 2 and check if it's equal to 0 or not. This is representing x in the first case. It's only like syntactic sugar from Scala. And a more complex example that we can do, it's for example, we are now defining an indivisible by x function that it's also using curring, and the first argument list is taking an argument called n, and the second argument list has only one argument called x. In this case, we are only checking if x modulo n is equal to 0, returning a boolean, and the type is inferred, as you can see here. And we can call the filter function again, passing the integer list, and as the second argument list, we are performing a call to n divisible by x and providing only the first argument list. What's happening here is that the Scala is detecting that this function called filter is expecting a function receiving an integer and returning a boolean, and while calling this function called indivisible by x, we need to provide the second argument list, which is a function taking an integer and returning a boolean. So the types are matching, so the compiler succeeds, and we can have the result that is exactly the same as before. This is mostly for the educational purposes because this is very complex to perform only an easy event checking, but it's useful for trying to teach you about the curring technique. Another example is that we can define extracting a function from indivisible by x, providing only the first argument list. What is happening here is exactly the same. We have the type that we are expecting, and it is exactly matching the type that indivisible by x, providing the first argument list, is requiring. So this match, and we succeed. On the other hand, is we don't provide the expected type of the function, this is going to tell us that there is an error, because in this case the Scala compiler doesn't know what we really want to do. We might be trying to call indivisible by x providing all the parameter list, or we could be trying to extract a partial function, a function from indivisible by x, and the compiler doesn't know, so we get an error. A way to overcome to this is to use the underscore to tell the compiler, I want to provide the first argument list to indivisible by x function, and if the function have more argument lists, I don't care. I just want to provide the first one. So in this case, we are getting exactly the same result as before, as the first is-event definition, because we are telling the compiler that we don't care. And one example at last, you can see that we are invoking the function, and it works. It's working, telling us whether a number is even or not. Curring might be complex to you if you are not familiar with functional programming, or if you haven't used this before, but think a little bit about it. It can result very useful in several situations. Now, starting to talk about the case classes, the way for defining a case class is prepending the case modifier, and every attribute to the class that you are declaring, you are not required to write a modifier like val or bar. We haven't talked about bar, but bar is a way to tell Scala that the attribute is a variable, that it means that we can modify the attribute after it is assigned. In this case, by default, all the elements are values, so it's an immutable class. And this is exactly the same as a class, but it has some advantages because the compiler is generating code by himself to make our lives easier. What can we do with case classes? This can help us a lot while creating domain-specific languages, because we can call the constructor, or we can create a new instance of the class using the new keyword or the new modifier, and this is very useful for domain-specific languages. Another thing that we can see in case classes is that equals method by default is already included in each case class, and If you are familiar with Java, in Java, when you create a new class, you usually are required to define the own equals method and hashcode method. Scala by default creates hashcode method and equals method for you when you declare a case class, and it's very useful. And ignore this because this is a mistake that I made in the presentation. Case class by default is immutable, as I already told you. If we try to reassign an existing attribute, we are going to get a compile error because by default everything is a value. But the way to overcome to this is to use the copy method that is created by Scala compiler, and this allows you to modify some attributes of the class. Like in this case, we are modifying the name. In the previous case, we were modifying the ID, and we can pass several arguments in a comma separated way, and we can modify all at once, or just two, or just three, whatever number you need to modify. And as you can see here, by default, we already have the toString method as we mentioned before, which is very useful. And not everything is beautiful in case classes, because as I told you, a case class is immutable. And suppose that you have a more realistic example. You have an organization, that the organization is having a list of users that belongs to the organization, and it also contains an address, like the address of the organization, and the address contains a street and also contains a number in order to identify the address. And this is dummy, but it works for the educational purposes of this presentation. We have a case class called a street that only has one attribute called name. In this case, what happens if we want to modify only the name of our organization? Suppose the organization had moved some squares in the same street, and we are required to use the street. We have created one organization with some values, a single user, an address, and a default number. And if we have to create that, to modify the attribute name from address, we are going to have a hard time, because we need to copy the whole organization, then we need to copy the whole address, and when we are in the tier line, we already have forgotten about what we are trying to do, because this is too complex and too much code. But the idea is exactly the same, to start copying everything until we get to the deeply nested attribute. And this is awful in my opinion, and can give you some hard times when dealing with immutable data structures. And there are some alternatives, and the usual way, or more popular way for updating immutable classes, is using a technique called lenses, that allows you to modify a nested attribute in a very easy way. And I can tell you to look at the Monocle library from Scala. It's in GitHub, and the Monocle library had several utilities for handling several things in case classes and immutable data structures in Scala. And there is also another simpler solution. That is a library called QuickLens, that allows you to generate this complex code, but using a cleaner syntax. Like suppose that you can use something like organization.address.street.name.using equal to new street, and in compile time, the library or the compiler plugin will help you to generate this code at compile time, but you are not required to write this complex code. It's useful if you can take a look to that library. Then using case classes, we can get to another concept from functional programming called algebraic data types. And algebraic data types, you can see like one type created by combining some types. And one example that we can see that it's very simplistic, it's to making a calculator. Suppose that we are defining a calculation using a trait. In Scala, a trait is similar to an interface in Java 8. I mean Java 8 because you can have methods, implemented methods in a trait. And we can also have some case classes extending this trait. And one important thing about this is we have prepended the sealed keyword. The sealed keyword means that the Scala compiler will try to look to every subclass of calculation in the same file where calculation was defined. And this is very useful for algebraic data types, and we are going to see one example of this. And we are declaring the case classes final because we don't want anyone else to extend indirectly this calculation. And for example, we can have a literal that it's simple a value, in this case an integer. It's for educational purposes. In a more realistic way, we are very probably not going to use an integer. And we can represent an add operation, having two calculations as arguments. We can represent the subtract operation and multiply operation as well. And the algebraic data types makes very easy to evaluate them in using another technique called pattern matching that it's also from functional programming. You can see a pattern matching like a switch and case, but more sophisticated. You can do several more powerful things. Like in this case, we are telling that we are going to match on the calc argument in this eval method, and depending on the result, like if the argument is a literal and it has an x, we don't care what the x has, but we have an x. And notice that we are extracting the argument from the literal. In this case, it means that evaluating a literal, the result is only the value from the literal. And supposing that we need to evaluate the add operation, we are extracting both arguments. We are extracting the a and we are extracting the b. This is very, very, very powerful. And in this case, we can evaluate every calculation in isolation and perform a sum on the two results. The same is for subtract. But what happened here? We haven't evaluated the multiply case, and as I told you before, the calculation is an algebraic data type having the sealed keyword that we can see here, and this helps the compiler to tell something like, I know that calculation is not going to have more subclasses, so I am asking you to at least evaluate each possible case, and we are getting a warning from the compiler because the matching is not exhaustive, because we are missing the multiply case, and it's telling us that it will fail when calc is equal to something with multiply and two placeholders, because anything that is in multiply will make this eval method to fail. It's something very simple that can help you to complete the method and avoid errors at runtime, but to detect it at compile time. It can save you a huge amount of time. And one of the last topics to cover here is about error handling. You are very probably familiar with the way of dealing with exceptions because it's very commonly used in several common languages like Java, Ruby, Python, JavaScript, C++. Only C doesn't have exceptions, but C++ has. C#, several common languages and popular languages has exceptions, and Scala supports handling exceptions because it needs to, but it's not the more recommended way, because one exception can be seen as a go-to. You will never know unless you dig into all the code to know which exceptions can be thrown from a method call, and it's a very complex way to deal with error handling. Another thing with exceptions is that exceptions can be used for failure cases, like cases that you are not expecting, like a network failure or a connection failure. And if you avoid to use exceptions, you can differentiate very easily between errors and failures. As I told you, a failure can be seen as a network error, and an error can be seen as something that you expect that can happen, like validating a username and the username already exists, the email is not valid, and this is something that you can detect as an error instead of a failure, and you can isolate this by I will let exceptions to be failures only, and every other case I will handle the error, because most of the time you need to handle the errors, and this is a way to separate these kind of things. Scala have another grapper that it's called try, and we are using the parameterized type. It means that the result will be something from type T, which is a more functional way for handling exceptions. And we are not going to cover this because we already have talked about disadvantages of exceptions. And there are another classes that are not were not really designed to deal with errors, but they are commonly used for handling errors because they are useful to do that. We have the option type and the error type. The option type is the way to avoid using nulls, and it means that you can have something and you can have nothing. In the case that you have something, you can perform operation over this result, or in the case that you have nothing, you could know that something wrong happened, that like an error. The disadvantage of this is that you don't know what exactly happened. You know that something went wrong, but you don't know what went wrong. And error is another type that can help you to do this kind of error handling. You can see error like an XOR, because it can have one type or another, but exactly one result only. In the case of the left type, it means that you have an error, and in this case you have what error happened in the left type. You know that something wrong happened, and you know exactly what happened. And in the case that the operation that you did was successful, you know the result in the right side, and you know, and that's why error had two types. Error, it's a little bit more complex than option, and in this case we are going to talk more about option. And if you look to some Scala code bases, you are very probably going to see options, because options are the way to dealing with nulls. The way is, one advantage is that you are forcing the programmer or the people using your library or using your your code or your code base, you are going to force them to handle the error case instead of exceptions that you can miss them. And talking a little bit more about option class, the option is algebraic data type again. It can have only two possible subclasses, which is something or nothing. In the case that you have some, you have the result. In the case that it's none, it means that you have nothing, no value computed already. And this can be usually seen as the null case that you can see in several code bases, with the advantage that this is typed and you are required to handle the missing case in compile time. If you forget to handle the missing case, you are going to get a compile error, and this avoids you several kind of issues. Trying to look to a more realistic example in this case for handling option or error to handle errors. Suppose that you are writing a web service that is used for creating some users. You have some arguments, and that like a request having some arguments, and you also have a model like the model in the database that is storing the user. The only difference is that here in the database model you have an identifier that usually is server-side generated from the database, or an UUID that doesn't apply in this case because the type is an integer. And we are going to suppose that to write the validation and parsing operations for this request. What we are writing here are some dummy methods because they are very simplistic to be a real case, like parsing a name or a last name. We are only checking if the string received string has something, or that is considered blank, like having nothing, or it contains only spaces, and we are returning the option. like it can have none or it can have some, and the name is normalized in this case, removing spaces, extra spaces. And also we can have a method for parsing the age, like we are defining a valid interval like from these numbers and returning only a valid age in this case, and if not, it means that the age is not valid. As I told you before, we don't know why the value is not valid, but we know that it's not valid only. And we can parse a gender, and a gender can be seen as a male or female only, male or female strings, and we are using pattern matching again. This bytes means that we are handling several cases for one result, in this case to get a gender, and here the underscore means if it wasn't matched before, I don't care what the value gender have, but I want to return nothing, none in this case. And we have another dummy method for creating a new user ID that is a static integer, that is a 1. It's for compiling purposes of this example only. The way for dealing with this is using the common operations for collection, like flat mapping or mapping, that you might be already familiar with. This is used for dealing with collections. And this is another way that you can see the option data type. An option data type can be seen as a collection having at most one element. It can have 0 or it can have 1 only. And we are nesting several operations, like if I can parse the first name and then I want to flat map over this option and have the first name unwrapped here. I will do the same for the last name, the same for the age, and the same for the gender. If all the values were valid, it means that the program will get until here, and we can create a new user. And this means that the method is returning an option parameterized with user type that will only return something and the user if all the parameters are valid, the parameters from the request, I mean. And you are not going to let me lie, but this is really awful. This is horrible to write. This remembers me to Node.js with its call but hell nested several functions inside another functions, and this is awful. But fortunately, we have the for comprehension syntactic sugar, and we can deal with this like in a more in a similar way to handling collections. Using this is for is different to the usual for that you see in imperative languages like Java or JavaScript. And in this case, this is equivalent to the horrible example that we just saw. And the way for dealing with for comprehension is the first name will take every value that person name is returning. In this case, you can see like a for each in Ruby or Java, like first name is the value that is taking, performing a for each in the result from person name. But this is more linear than nesting several cycles, and we are doing exactly the same for last name, with the difference that in this case we are telling that last name is not really mandatory, and in the case that the user is not providing it, we are giving a constant, not given in this case, and last name is going to take what the user provided or not given. We are doing the same for age and the same for gender, and we are using the GL keyword for telling I will return the user. And this is a more cleaner way, and for comprehension have some disadvantages, but I'm not going to touch them in this case because we are taking almost all the time in this presentation. But this is a very useful way. If we want to return all the errors that had happened while parsing the request arguments, there are ways. Either it's very difficult to do it using error. With error you can return only the first error. Of course, you can write some helper methods to return all the errors in error, but there are some libraries like Scala C, CATS, or even Scalatic that had made some very useful classes for dealing with this kind of scenarios, and you can use for comprehension and returning all the errors using one of these libraries, and it's very useful for writing REST services in a very clean way for validating everything, because you always need to validate what a client is providing. And as a last thing about option, we can see the examples running, like creating an invalid request because the edge is too low, too small. We are getting none in both methods, and we can get some when the edge is correct, is in the valid interval. And the last thing is that using option while calling some Java libraries that can return null is not so good if you create them using the sum object, because you are going to get things like sum of null, which is not what you might be expecting. And the way to overcome to this is creating an optional value using the option syntax, calling this method from option, and this will validate that the argument is not null. And the last way for dealing with options is using get or else. If you want to ungrab the element that is contained, you have to use get or else, and you are forced to handle the missing case. That is like this, returning something default. And option is very useful. I recommend you to take a look because there are several more things that you can learn about the option. And the last part of this presentation is talking about detecting more errors at compile time than in runtime. Suppose that we have the same database model for one user. You are going to create one user with some arguments, the name, last name, age, and gender. And what happened here is that you are very probably working at midnight, almost missing a deadline, tired with having drank several coffees now, and you are tired, you want to sleep, and it's very usual to start copying and pasting variables, and you can get this kind of stuff. I hope you have never done this, but I have done, and I have ever regretted copying and pasting values, because in this case you see that you are pasting the name as the last name and even as the gender, and the compiler is working because the compiler is only expecting a string or another string, an integer and a string, and it doesn't have something more related to business rules, which means that if you provide the correct type, the compiler will work. And this is an example of weak types because it doesn't have several things. It's not stored in the context of your application. Like the age cannot be negative, but you can provide a negative value here and it will work. But it doesn't make sense in this application. And the way is using more strongly typed values, like for example, one way is to creating one wrapper for every possible value, like a user ID, first name, last name, age, and gender objects. And this means that you are not going to be able to copy and paste some values, and because you are going to get a compile error. And in this case, we are using the trick of extending the any value class, and this means that you are going to define a wrapper that only is valid at compile time, but at runtime the wrapper will disappear and you only have the primitive value, like the in Scala is the object, the int or string, which means having more typed values with no runtime overhead. This is something very useful. But we already have the problem that someone can start doing new user ID and passing a negative ID, which is wrong. So there are two simpler ways to overcome to this. And the first way is creating a private constructor for this class, in this case the age class, which means that we are only able to create an instance of this class using the same class or the companion object. It's one of the applications for a companion object. And we have an auxiliary method called from int that receives an int, performs a validation, and returns something with the age in the case that the interval is satisfied, and it returns none on the other case. The advantage of this is that you are forced to validate the case when age is invalid, and you are not more able to create an age instance in any class. This allows you for more type safety and to avoid making some mistakes when you are working late and trying to meet a deadline. And the other way for doing this is using algebraic data types, like declaring a gender, having two subclasses, male and female, and we can use pattern matching in the companion object to create something like this. And again, we are forcing the programmer to validate the missing case or the bad case for the provided string, because this string, it can be only garbage and we don't know what it is. But we know that male is a male and female is a female type in this case. And again, we are matching to the otherwise case or anything else. And again, the bigger advantage of this is forcing the user or the programmer to validate the error case. And Scala also have enumerations and enums like in Java, but I personally don't recommend you, because enums are throwing exceptions in the case when you pass some invalid value, and I usually prefer algebraic data types, but it's up to you to decide what to use. And Scala is a very extensive language. There are several topics that we haven't covered yet, like features for performing asynchronous operation in a more easy way. Not everything about features is good, but not everything is bad, and as several things. This is similar to the async keyword that you find in C#. We also have non-strict arguments, like evaluating arguments only when you need them and not always. And this is one of the things that allow us to create domain-specific languages. This can be seen similar to lazy evaluation. Scala have a tail recursion optimization that it also has some advantages and some drawbacks. We can talk more about implicit. There are implicit methods, implicit classes, implicit values. One application of implicit is creating extension methods, as we saw in the first slides. We can talk about macros, like the macro for quick length for modifying immutable data structures in an easier way. Slick, for example, have another macro for evaluating SQL queries in compile time. Like if you write a bad SQL syntax or a column that it's not in your MySQL schema or Postgres schema, compiler would complain, and it's very useful. We can talk about type level programming, which it's a more sophisticated way for programming with types instead of programming with values, and this can help us to reduce the number of runtime errors and detect several errors at compile time. There are monads like option. Option is a monad. It's a functional programming concept. We haven't talked about immutable and mutable data structures. There is the actor model from Akka that is inspired from Erlang. That it's a way for scaling more easily in several situations. Not good for everything, but very good for several use cases. There are reactive applications for reactive programming that Scala is very focused in this topic. And there are very interesting functional programming libraries like Catus or Scala C, and we could also talk several things about microservices, like building microservices with Play framework that is very popular, Finatra, Akka, HTTP, and several other frameworks. For database access, we have several libraries as well, like Slick that I mentioned in the macro topic, and we have Doobie that is a pure functional programming layer for accessing your relational database models. And there is also things like Scala, like JDBC, Enorm, and several other frameworks. I hope you have enjoyed this talk as much as I have enjoyed talking, and thank you for your time.